All right, so we've had servers for a really, really long time. The whole idea of having a remote computer on the internet doing things on our or app's behalf is something that's been going on for ages. If we look at early precursors to that, here's the machine from 1940s that isn't quite the same as what we use today, but it's similar. There's a central device, it happens to do some computation, and it sends it back to whoever is requesting it. This is the common client-server model that you may have seen or read about over the years, or if you studied computer science or anything with computers, you would have seen it's a core part of how a lot of modern computing devices and solutions tend to work. Now, the part to highlight is that when we think of servers today, we still use them all the time. There's a very good chance that you're viewing this in a browser or on a device that is accessing internet. And for that device to work well, there's a web server. There's a web server that happens to serve HTML, CSS, JavaScript for all the various websites that you're using. Each website has one or many web servers and so on. If you tend to use email a lot, there's an email server. There are app servers that run code and process things on your behalf on a remote machine. If you do storage activities, there's file servers, databases, auth. There's a bunch of different activities today that are all covered by what a single server or what individual servers can all handle really nicely. Now, the question is, if we had to start thinking about servers as part of our development, we're building an app, we need to have some capabilities that can only be done by a server, what options do we have? And there are two popular approaches that we can rely on today. The first one is the managed service approach. This is the one where we are pretty much the maintainer of all things related to that server. The second one, an emerging and popular trend that you're going to see a lot more of going forward, and the star of this particular video, it's serverless. This is a world where we don't worry about servers at all, but we worry more about what exactly we're building and what exactly we want to deliver. So let's focus on the infrastructure and more on the things that we want to build and ship. And so we're going to look at both these approaches just to get a better idea of what the lay of the land is right now, and then we can go deeper into what makes each of them good and some of the areas for improvement. So we'll start with managed servers. When we think about servers, for the most part, this is historically what everyone else talks about, what we think about, and so on, because it is still very popular today. The general approach for working with a managed server is this. You go to a service provider, you pay them a monthly fee, and then they give you access to your own server that happily runs 24/7. And it's yours, so you can do all aspects of whatever you want on it. You can install things, you can configure things, and you basically manage all aspects of that server's life. Now, when we think of managing a server, there might be ideas of like large, clean machines with like a lot of fans blowing that are a lot of cables and require all this configuration. That is one way of thinking about it when you go really deep into hardware and infrastructure physical layer of what servers do. But there's a more common layer. The way that you and I would probably work with a managed server is we happen to go to a service provider. For example, this is Media Temple, a service provider that I use for a lot of the website's hosting needs. And you pay them a monthly fee and say, yep, I want a particular server with these kind of hardware capabilities, and I want to basically just pay you the money, but I have full access to all this what the server provides. If I want more details, I also use DigitalOcean, which gives you a lot more configuration out of the box on what kind of database engine, what kind of hardware configurations and various capabilities. But the big thing really is that kind of like customizing a pizza for your own needs. The way you deal with servers is that you have a basic solution. You tell them what you want, but ultimately you customize and manage all parts of it, including eating it all as well. Not that I recommend that you go and eat a managed server if you can even physically go and find it. And the way you manage a server, again, is not through basically the arcane kind of things you might see in movies or really complicated TV shows, but you're given a dashboard. You're often given a dashboard where with just point and click access, you can go and make all the various changes your server gives you the capabilities to modify. Here's an example of what you see for the Code.com website on, again, Media Temple, where they use Plesk as their management service. You can go and modify all aspects of how the site is configured and run, which makes it much easier than me having to go and do really arcane things. But again, because you have full access to what the server provides, you can actually log in as a root administrator, and go and make more detailed under the hood changes if you so choose. You have full access to all of these capabilities. Now, the thing with managed servers is that they have a lot of things going for them, which is why they've been so popular for decades and continue to be popular today, but they do have some rough edges. And let's look at what some of those rough edges are. The first one is pricing. The thing about managed servers is that we pay a flat fee, and this fee covers the times that our server is actually doing work, being useful, but it also covers the times our server is sitting idle, not doing much, not being of much value to society. In those cases, though, this leads to us paying more than what is ideally optimal in terms of what we're getting. And here's an example of a dashboard of usage for a monthly server that I pay a fee for. And in this case, notice that the amount of heavy-duty work the server does is only isolated to about 3 spikes over a period of a few week period, but because I'm paying a flat fee, I'm still paying for all those times. The server really isn't doing a whole lot. That's not exactly very great, not very optimal. The second one is scalability. There's a fixed amount of resources a server will be able to handle. When we looked at configuring a server or provisioning a server on both Media Temple and DigitalOcean, there were some settings around like how many CPUs or how much memory and how much storage will be needed. And the thing is, those are often hard caps. So there's a sudden influx of requests and our server is being asked to do a whole lot more work. Our server will basically start dropping requests that exceed its capacity, and that's never a great user experience. You can imagine that if you have a bunch of users, some of them will be able to access the content and be able to be successful in what they're doing, and another set will basically find themselves getting an error message or getting really slow performance, or the dreaded 429 error, which you all may have seen at some point while surfing the web, where that's that classic HTTP error code for when the server is too busy to handle the request that you're dealing with. The third problem with managed servers is where they're geographically located. Because our audience will probably be worldwide, but our server, for a variety of good technical reasons, will be geographically located in only a single region. And as we know from a lot of things, including the video recorded on what CDNs, content delivery networks, do, the closer someone is physically to a server, the faster the request to the server will be heard, processed, and communicated back, which kind of makes sense. The networking is a hardware problem in some ways, where a signal has to go over wire or some form of a medium long distance, and the longer the distance, the longer it takes for the signal to go in and out and so on. And here's an example where you can imagine if our server is located on the western coast of the United States, those devices that are accessing it, that are closest to it, will have a much faster network performance than something that is much, much further away. And so this is one of the things that managed servers are not very great at being able to handle for us. And the last one, which is kind of obvious but worth double clicking on, is that because we're managing our own servers, we're responsible for everything, for making sure it's up to date, making sure it has all the security patches on, making sure that any applications we install is properly configured. And of course, if anything happens to go wrong with the server, where it goes offline because of a misconfiguration or a typo in a config file, or there's a massive spike in traffic, it's again up to us to deal with it as well. Now, the various service providers will offer assistance, but the bulk of it, though, is entirely on you and me to figure out. So here's a real life example from just earlier, last year, where a routine upgrade ended up causing some major downtime, and it took about 2 days for me to work with someone else to figure out what's happening and go ahead and fix it. So these are the kind of things that are not great unless you really enjoy this, because what I care about is building web apps, mobile apps, and so on, probably the same as you as well. Mainly maintaining and managing a server, not always very high on my list of things to do. So that brings us to the more modern approach that we see today, which is serverless. And this is a world where we don't worry about servers at all. We just write code or provision services and let someone else out there in the cloud somewhere, handle the messy server details on our behalf. And the first thing to call out about serverless is this. The name serverless makes it sound like there is no server involved at all. That is not true. In a serverless world, we still have physical devices known as servers. The biggest difference is that there's no single server or collection of servers, for that matter, with our name on it that we have to manage. We bypass the whole provisioning and configuration part of working with servers and jump straight into writing our code, enabling services and so on, as if a server has always existed for us. And we talked earlier about the kind of activities that servers typically solve for us today: web, email, apps, storage, database, and all of these things will continue to work in a serverless world. And the way you work with serverless is you work with, again, a service provider, and there are a handful of really popular ones. You have everything from Azure, Amazon, AWS, Google Cloud, to Cloudflare, and also Firebase, which is one of my favorite ones we'll talk about in a little bit later. This is the primary way you go and say, I want to go ahead and build something that is going to be running a serverless solution, and you don't focus on servers, you focus more on the capabilities or code that you want to expose. Of course, you can also then all of these examples, you have code here. Here's a version of a serverless solution where I'm just making a web request and I'm creating an endpoint that someone can call to get some work essentially done. And notice that I'm writing code. At no point did I have to specify server. Like in the old days, it would have been a situation where I have a LAMP stack, for example, if I'm going really far back and I have a PHP file that I need to edit, update, and then upload to my server. All that is taken care of for me. And if I want to, I can just use the console to deploy and make changes. And the end result is a server is being used, but it's a server that I have no idea about. I don't know what the IP address for it is. All of that is completely abstracted away. And the major tagline you'll see with serverless across all the various serverless providers is the goal is to focus on code and services, not servers. And that's really the big selling point compared to managed servers, where you focus on code and services and you also focus on the server as well. So it's one thing that you're not focusing much on. And what this model allows is it builds upon and improves some of the gaps we identified with the managed server offerings we looked at a few moments ago. So because computing resources are brought online on an as-needed basis, that we only pay for usage. We don't pay a flat fee typically, you just pay for the amount of computation that's actually being used. Here's an example where what I'm being charged for is not a flat fee on a period of time, but it's based on the amount of activity, in this case, invocations of my serverless function, and how much work it's doing. And this typically leads to more predictable pricing that is often lower, because this avoids the peaks and valleys you'll often see where people are accessing your site or accessing your code and you needs to be doing some work, and other times your server is not going to do any work at all. So it's more representative of paying for usage. The next one is scalability, because we're not controlling the servers, we're not specifying how many servers to deploy or anything like that. The amount of server resources available for us, it scales. It scales based on number of requests being made. You have a lot of requests, you get more servers. You have fewer requests, you get fewer servers. But the important part is this is all done automatically. We have to do absolutely nothing to get the scalability for us. So the earlier example we saw earlier, if we have a handful of requests that are being made, our server will handle it just fine. You have, in this case, one single server solution. But if that happens to balloon to many, many requests, no problem. If the amount of server resources available will scale and increase accordingly, which is pretty nice. And the next part, which is an emerging area in the world of serverless, is that typically the same problems we had with your serverless server and your managed server is that they often had to be located in one geographic region. Now there are changes underfoot with a lot of the providers now giving you the ability to have your servers provisioned automatically closer to the devices and users that need access. And this really means that the average time for someone to communicate with our serverless server is going to be shorter. And just like we saw earlier, the less time we spend sending a signal back and forth over a network, that's a good thing. It saves you time, makes things faster. So here's an example where the exact same solution that we would typically write happens to work. It just so happens to be deployed to all these regions, and automatically users will get them for free. Again, nothing you have to do on your behalf. You just focus on code, focus on services. All this stuff is taken care of automatically for you. Now, serverless isn't perfect. There are some gaps, and there actually are many smaller gaps we can get into in the future. But one of the biggest issues is this. Because there's no server running 24/7, when a request comes in, often the first request after a long delay, that server has to be spun up. It needs to provision, needs to install things, needs to get ready to be able to react to any request that is coming in. And that delay can be anything from like a few seconds to maybe even a few minutes in some extreme cases, which is typically not great. You often want to have millisecond level of response time. So often these first requests suffer what's known as a cold start problem, which is the time it takes for a server to come online, which is similar to like us turning a laptop or desktop off and turning it back on and waiting for it to boot up and do all the things that it does. So there are ways to work around it, but it is definitely a problem that if you really want lightning fast latency, you will have to pay for it, and a serverless solution can still work for you, but there's some things you need to kind of make sure you dot the I's and cross the T's on. Alright, so we covered enough about the serverless world and the managed server world, and so now we're wondering, how do we get started? I want to kind of kick the wheels on a serverless thing and see what happens. So there's a lot of great providers you can use, but the one that I prefer is Firebase. It provides the right balance of ease of use, but also gives you all the capabilities you would really want, and the URL is firebase@google.com. Now, I'm a bit biased here. I do work on the Firebase team at Google as a product manager, and our serverless solution, making sure it's still really great, is one of the things I spend a lot of my time on. So, take that with a grain of salt, but I wouldn't be working here though if I didn't think it was a great product. So that's one thing kind of going for you in my recommendation for why you should consider Firebase as opposed to other solutions. So there you have it, a very quick overview of what the world of servers really looks like today, and the two solutions that we can rely on. One is the managed server approach, where we pay a monthly fee and we handle all aspects of working with its server, both managing all the capabilities it provides, as well as writing the code and provisioning the services and so on, which gives a lot of power, a lot of flexibility, but is a lot more work. Contrasting that, you have the serverless approach, which still gives a lot of power and flexibility, but you no longer need to worry about the hardware itself. So you can still accomplish all the things you would do in a managed server world, but you just have to worry, focus more on the code and the services and less on being able to, micromanage every detail of what your server hardware and configuration actually does, which in many ways is something you might want to do. And so I'm not saying that serverless is the perfect solution in all situations, or managed servers are the right solution in all cases, but at least hopefully this gave you enough information to help you make a better, more informed decision on what kind of solution you want to employ. And this is a complicated topic, so if you have any questions, please post in the forums at forum.group.com, where I and others will be happy to help you out and explain more about servers and all the various things that can go well with them and go wrong with them. Next steps, if you like this video, tell your friends and enemies. If you didn't like this video, tell your friends and enemies anyway. Hit subscribe to be notified of new videos that help my follower count go up. Follow me at Krupa on Twitter and Facebook and other places people named Krupa typically hang out. You'll get bite-sized updates on web development topics. Lastly, if you enjoy reading content like this, buy my book. I have a variety of books on multiple web development topics in both paperback and Kindle editions. They make great gifts, they make great paperweights, and if you have that one table that is wobbling a bit, one of these books is the right size to make that wobble go away as well. So, hey, multi-purpose solutions here. That's what I'm about. And with that, I will see you all next time.